conditioning, and I had enough people request that they wanted an air conditioning training, so we got a hold of our friends here at Spheros, and we have Johnny Flores today presenting on air conditioning maintenance and just keep them going, how to work on them, what things to look for, that kind of stuff. So our last meeting was held on February 25th, 2026, and it was Roger Herod with Matthews Bus Sales presented on the Thomas Electric bus. And he talked about the Gen 1 chassis. He talked about how they use two batteries. Both batteries are 400 volt, so it's a total of 800 volt is the system. They've got an e-powertrain Accelera axle in the back, 295 horse with 2-speed transmission. We had he talked about the road speed, 0 to 60 in 45 seconds. Max road speed was 45 to 75 miles an hour. They are utilizing a new dashboard, which is keeping up with the times, keeping up with, more like the trucks, kind of like the other two, Bluebird and International are doing. They have two coolant systems. They have a clear reservoir and a black reservoir. The black reservoir is for the heat. The clear reservoir is for the cooling of the electrical system. They are using a scroll type oilless air compressor, which is supposed to last a lot longer, be a lot more efficient to build the air for the system. It uses an IntelliPark brake system, which they've used for a while now. And in the beginning, I know there were some issues with it, but I think they've got that all worked out. But it will not release when the bus is charging. So that's kind of unique. So long as that charge cable is plugged in and the bus is receiving a charge, it will not release. So nobody can drive away with the cord hanging off the side of the bus. They also had tire pressure monitors on the sensors in all the tires. So that's something new. I'm thinking the rest of the manufacturers probably are going to get on board with this, something as we're going along. It is a light on the dashboard, and I'm sure it's going to be a DOT failure. I will find out and let everybody know, because it's just another light on the dash for our DOT inspections. But it is programmable to your air pressure. So whether you're running 95 pounds or 110 pounds, you can set that. So that's new. There are antennas in the front and in the rear, so it uses a dual antenna system. That's for the tire pressure monitoring system. When it comes to the training, they still have the HB1, which is drivers. Pretty much anybody that is going to be around or using these electric buses is going to have to be HB1 certified. HB2 is for mechanics, just normal basic repairs, and HB3 is for factory and dealer repair. That's a 3-day training class. And then what they want you to do, and this is what we learned when he was talking about that class, is document the problem and contact your manufacturer. They will advise you on how to go about fixing it, whether you need to take it somewhere or it's something that you can do. So that's kind of new. It's a little different than the way that they've previously done things. But that meeting was recorded and it is on our channel. So anybody that wasn't there, or you want to just get a recap on the information, just tune into the channel and you can view that there. So today's presenter is Johnny Flores with Spheros. He's going to be presenting, like I said, on air conditioning operation and maintenance as we're into the warmer weather getting there. I know we had 60 some degrees the other day, almost 70. won't be long. We'll all be working on our air conditioners. So go ahead, Johnny.
All right, let's go ahead and get started. I'll go ahead and start by presenting my screen real quick. Let's see here. So, okay. Is it sharing on your guys' screen?
There you go.
There we go. All right. So, thanks for everyone that's here. Thank you for attending. Today's pretty much going to be about your typical basic AC preventative maintenance, basic operation, how to make sure that the air conditioner just pretty much lasts for a long time. Like Dan was saying, my name is Johnny Flores. I'm one of the field service technicians that we have here at Spheros. Best out of the West Coast. I'm in California. So right now it's currently probably in the mid 90s. That's what we're hitting right now. So everyone's been using their ACs already for about a week or two already. So we can feel it out here. For the warranty, as far as we have Dakota King and David Tice. We have Dakota Elswick at our sales, and of course, Mr. Chris Porter, the director of service, who wasn't able to make it here. He has a lot of allergies; they're pretty bad, and he lost his voice. A little bit about me before we head in and move on is I've been doing HVAC for going on 7 years now. So I first started doing residential like commercial, your typical home ACs and heaters, the rooftop units, your split systems that are you find out there like at restaurants, stuff like that. I did that for about 5 years, give or take, and then I moved on to this side now, which is a little bit different, but still the same concept. Just this time you have your HVAC equipment on wheels is the way I like to think of it. But I've been doing that for 2 years now. So let's go ahead and move on. So this here is the circuit overview of the refrigeration cycle. For those of you that are not familiar, this is something pretty much very good to look at. It'll help you understand the refrigerant cycle because since you're going to be working on ACs, for those that do work on ACs, knowing the refrigeration cycle helps you out a lot, helps you identify the issues a lot. Once you get this down, in my opinion, I find it pretty easy to figure out what the problems are. So we'll start off with the compressor and the clutch. So the compressor engages, and then you have hot, high pressure gas refrigerant coming out through this red line right here. So it comes out in a hot, high temperature vapor gas. It goes through. You have a pressure switch here on the high side, and you also have one on the low side. But your high pressure switch is pretty much in charge of measuring the PSI or the pressure of the discharge line. And if for whatever reason it senses that the pressure is way too high, that pressure switch will read that pressure and it'll pretty much say, we have way too much pressure on this line. We need to shut off the system. And it's just a safety switch in all reality. So whenever the pressure gets too high for several reasons, which we can get into a little bit further into the presentation, it just pretty much helps prevent the compressor from going bad. So like I was saying, it comes out in a discharge line. It comes out in a hot, high pressure gas. It goes through something called a condenser. So that's called the condenser coil. You have the pressure or the refrigerant coming in through here. And then you have the cool ram air, which is like your ambient air that goes through the coil. It goes through the coil and then it comes out in hot air. So what it's doing is it's pretty much rejecting the heat from the refrigerant. So you have the refrigerant coming in, it's a hot, high pressure gas. And then right around the middle is when it starts to change state. So the refrigerant temperature will start to drop a little bit, not too much, but it'll still be warm. So it'll start to drop, change state. It's called subcooled. That's what the refrigerant said. That's what's going on in the condenser. It's being subcooled. So what ends up happening is that it changes states. And once it finishes down here at the bottom, it comes out in a liquid form now. So now it is still considered a high pressure state, but it is more of liquid now. And of course, it's warm. If you were to put your hand on the hose, or some systems come with copper lines, on this one, this is going to be a lot hotter. Your discharge line is going to be a lot hotter than your liquid line. because of the condenser, of course. So it comes out into your liquid line, and then it goes through a filter dryer, liquid line receiver. It just depends what kind of component your HVAC system has. And it goes through the filter dryer, which is meant to pretty much filter, remove any moisture, any contaminants, debris out of the line, out of the refrigerant circuit. So it goes through there, and then it comes back down, and it goes to something called an expansion valve. So there are many types of expansion valves. You got your expansion valves that have a sensing bulb that help it adjust uh, the pressures going into the evap depending on the load in the vehicle. You have your block valves, and then you have your orifices. So these are pretty much in charge of stepping down the refrigerant pressure. So it'll come into a warm, high pressure liquid, goes into your valve, and it comes back out in a cold, low pressure liquid. It's still liquid, but it's cold now. So now that it's cold, it goes to something called an evaporator. So this evaporator is meant to absorb the heat from the inside of the vehicle. So if your bus is really, really hot, it pulls that hot air out of the bus. It goes through this evaporator, which is now cold because of that cold, low pressure liquid. And then it absorbs the heat, and then it ends up supplying cold air into the bus. So you have your cold, low pressure liquid going in. Same thing as a condenser. Right around the middle is where it starts to change state, and it starts to pretty much boil. So when the refrigerant boils, it begins to superheat. That's what we call it. So once it boils, then it starts changing state again, and it goes back into a vapor. Cold, low pressure gas vapor. Goes through here, and then we have another pressure switch as well. Same function as the one for the discharge line. Measures the PSI, the pressure of the gas. And then if it, for whatever reason, it feels like it's too low due to a possible restriction or even a leak, it'll shut the system off to prevent the compressor from running pretty much on empty. Then you have your typical service ports. So that's where you'll be connecting your gauges to measure your pressures. So this is pretty basic. Like I said, this is pretty important. So if you memorize your lines, what happens in your condenser, what happens in your evap, and all your other components, if you memorize this, and in my opinion, you'll be able to figure out just about any situation related to HVAC, of course. So move on. Returner filters and evaporator coils. So why is it important to ensure the evaporator filter is clean? Well, dirty filters or coils restrict airflow. The evaporator, like I mentioned, needs airflow to absorb heat. If for whatever reason your evaporator is dirty or your filter is dirty, then you're going to start having issues. If you don't have enough airflow to go through the evaporator because the evaporator is already cold, it's going to end up freezing. And if it ends up freezing, then by then you have a chance that you might start sending liquid into the compressor, which is definitely what you don't want. You don't want to start putting liquid inside your compressor because it'll start to slug, and then eventually you'll kill it. You'll kill that compressor. With reduced airflow, you have less cooling performance. So it can lead to poor cooling or coil icing and increased system stress. So if that filter ends up staying dirty for a very, very long time and it's not cleaned often at all, there's a big chance that the evaporator is going to be dirty as well. If you are on top of your game and you're cleaning the filter or you're replacing it as needed, then the chances of your evaporator being dirty is going to be a lot less because you're on it. You're changing that filter or you're cleaning that filter on a weekly basis or daily basis. It just depends on how often it gets dirty. You have those drivers that want to have the AC running, and we don't blame them. They want to have the AC running because it's hot outside, but they have to clean their bus right before their shift ends. So they're using they're sweeping the bus, picking up all that dirt, and at the same time, what they're doing is kicking up all that dirt, and the filter's catching it. So they get dirty pretty quickly. But if you're on it and you're actually cleaning your filters or replacing them, then you'll be okay with your evaporator. As far as cleaning methods, there are many different evap coils out there, cleaners out there. I would recommend you use one that isn't really acidic, because if you use anything that has like some sort of acid or is like really strong, what ends up happening is you'll end up eating the fins and the copper, the tubes on the evaporator coil. And if that ends up happening, then you end up causing leaks. Excuse me, leaks. So you want to go ahead and use something that is pretty much not acidic. There are evaporator coil cleaners out there that say they don't need to be rinsed. You just apply them and then you go ahead and run the AC as normal. I would still recommend doing a light, like light spray down. You know, if you're gonna go ahead and use something that doesn't require any rinsing, just go ahead and try and use something that some water just to spray it off a little bit. I wouldn't really leave it on there and let it dry, me personally. But you want to use something that is low pressure water, so a water hose or some sort of pump sprayer, um, bottles like your bottles that have the little trigger on there to go ahead and wash it down with water. And of course, you want to have a brush. So if they do accumulate a lot of dirt, then you want to go ahead and brush it off. And then you want to go ahead and add the coil cleaner on there and then pretty much hose it off after that. Your filters, like I mentioned, clean or replace filters as needed. Sometimes they're daily, sometimes they're weekly. It just depends on how often they get dirty. But regular filter and coil cleaning improves the performance and helps protect the compressor, which is what we want to protect the most because it's like the heart of the body. It's the main thing, the engine of a car. Without it, nothing's ever going to work. So that sums it up for the evap. Let's go ahead and move on with your condenser. Same thing as the evaporator, right? Except it has a different function, but it's the same process as far as cleaning it. Dirty condenser coil restricts airflow. Reduced airflow means less heat rejection because the condenser coil does reject heat. Then if you have less heat rejection, then you have your refrigerant. It stays hotter. It's not able to be subcooled. So if the refrigerant stays hotter, then your high side pressure increases. And if your high side pressure increases, remember you still have that high pressure switch on there, where if it feels like the pressure is too high, that pressure switch is going to cut the electricity off to the compressor so it won't engage to protect it. But once the pressure goes down, it'll run again. The pressure will build up again, and then it'll cut off the compressor again, and it'll just short cycle pretty much, which you don't want that. So if you have a dirty coil, it'll pretty much lead to poor cooling, high pressure switches like I've mentioned, and increased compressor strain. You leave the condenser coil like that, you leave a lot of high pressure building up into the system, and eventually you end up having something called the Black Death, for those that do know. And for those that don't know, it's pretty much this really nasty black acidy stuff that ends up building in the system because the pressure is so high and the refrigerant is being boiled so much that it ends up changing like state to this sort of acid sludgy stuff, and that will pretty much contaminate your entire system, and it ends up being a huge mess because for one, it kills the compressor, and two, it contaminates the entire system. So at that point, you will start having to flush a lot of components, and you make the problem a lot bigger than what it could have been. So just keep up with your maintenance, clean that evaporator, clean the condenser. Cleaning methods are pretty much the same as the evaporator coil, except in this case, if you're going to clean the condenser coil, you want to use a coil cleaner that is rated more for condensers and not evaporators. So you want to use the same function, low pressure water hose, which in my opinion is a lot easier because the condenser coil is outside. Sometimes they're on the top, sometimes they're at the bottom of the vehicle. So it's a lot easier to use a hose than to having to use a hose inside the bus. But same thing, use a soft brush for the heavy buildup. A clean condenser helps maintain proper pressures and prevents unnecessary stress on the system. So another way to see it is if your condenser coil is really dirty, it's like you trying to breathe through 10 or 20 masks on. You're gonna struggle, and it's not gonna be the same as having to breathe without a mask on. So that's one way that I like to see it. We'll move on. Now your compressor. So this here is our compressor. You want to do a visual and physical inspection. So you want to check the oil stains at the shaft steel, seal, manifold, and hose fittings. Mount brackets, check that the bolts are tight. Make sure there's nothing cracked. If the bolts are not tight on the compressor, then what ends up happening is, it's on a bus, right? It's on a vehicle. So that vehicle is going up and down hills sometimes. Sometimes the roads aren't the best, especially out here in California, they're not the best. So if the bolts are not actually tight, what ends up happening is your compressor will start to rock back and forth or side to side. And then eventually that bolt will break, or even your compressor can break as well. You want to check the belt for cracks, glazing, and proper tensions. Your wiring, inspected the clutch coil wire for shafting or insulation damage where it passes through the compressor body, which is this wire right here. Sometimes they're one wire, sometimes they're two wires. Your clutch air gap. So with the system off, you want to check the clutch plate gap, typically 0.3 millimeters to 0.7 millimeters. If you do have something that is a lot bigger or longer or wider, then it prevents engagement of the compressor. So most of the compressors that fail are caused by external issues such as airflow, an electrical issue, or mounting issue. It's not just the compressor itself. Um, I have seen before in the past where sometimes where your hose feedings go, your suction and your discharge go, sometimes those aren't tight, or sometimes because your compressor is running hot due to a dirty coil or too much refrigerant in the system, the fitting itself that attaches to the actual hose, that clamp or locator wears out. And what ends up happening is they start leaking from there because they run hot. So get into a habit of checking these compressors, making sure there's no oil stains, which is a pretty much easy indicator of a possible leak. Like I've said, make sure that the bolts are tight, and you guys shouldn't have any more issues after that. Now onto the orifice tube system. So we have many systems use different types of would you say metering devices or stuff like that. So in some cases you have an accumulator, and some of them you don't. So what an accumulator does, or what it is pretty much the compressor's guardian. So it ensures only vapor returns from the evaporator. It makes sure that the liquid stays, if there is any leftover liquid after the evaporator. It helps make sure that it stays inside the accumulator, because like I mentioned, you don't want liquid refrigerant going into your compressor. There is a desiccant bag inside that's down there that keeps the liquid refrigerant here at the bottom. So you have your inlet refrigerant and oil going in after your evaporator, goes in, goes down here. There's a filter right here at the bottom. The liquid stays down here and it comes out and it goes into back to your compressor. So you want to check the compressor for external damage and oil stains. If you see oil stains, you have a possible leak. This is how it looks like right here. We've had I believe it was Chris Porter who opened this up and looked inside it. So this is pretty much how it looks like. You got your desiccant bag here, and then you have your refrigerant going down. Boom, and then goes back up here. So these accumulators on orifice tube systems, you want to go ahead and make sure that these are replaced after any compressor failures. If you change the orifice tube, which is a metering device, or anytime the system is open to air. So these desiccant bags are only single use, so they're meant to be used once. The moment you replace a certain compressor, an orifice tube, like I mentioned there, or it's pretty much exposed to the ambient pressure, then you want to go ahead and replace that accumulator. You don't want to reuse it again. You want to make sure you add the correct amount of new oil to the accumulator before you install it. Failure to do so can starve the compressor of oil, leading to a compressor failure. So you want to make sure you add your pack 46 on these compressors, your oil. Once you replace the accumulator, and you can just pretty much put it inside the accumulator itself. So at the moment the compressor starts, it absorbs or pulls the refrigerant as well as the oil, and it stays pretty much lubricated. So these are on orifice tube systems. That's where you will find these accumulators. Let's see. Now, as far as filter dryers or TXV systems, so what the filter dryer does, and this is how it looks like right here, they pretty much remove moisture and contaminants from the system. So if you look closely here, we used to have we did a color update. So we went from blue to black pretty much. And the side glasses are right here. So these side glasses, this is the before and this is the new ones now. So you'll start seeing your side glass right here. This is on the liquid line. So if you look closely, while the system is running, sometimes you'll even see refrigerant flowing through it. If your tag is green, that means it's dry. There's no moisture in the system. If it ends up being yellow, then that means this ends up being yellow here, then that means you have moisture in the system. So this filter dryer pretty much protects the TXV and the compressor. Kind of the same function, but it's more on TXV systems. So if for whatever reason these filter dryers have failed, or they've done their job and they absorb, all the moisture out of the system, then depending on what's going on, whether it's dry or wet, you'll end up seeing a green indicator or a yellow indicator. So as mentioned here, key signs of failure or that it needs to be replaced. If it has a green indicator on the side glass, it's dry. If it's a yellow indicator on the side glass, then that means there's moisture present in the system. Restrictions. These filter dryers can get restricted. After a while, if for whatever reason the system is still contaminated or dirty, or you didn't pull a proper vacuum, the filter dryer, just like any filter, like those filters in your homes, they can get restricted. And once they get restricted, they get clogged up. Once they get clogged up, then at that point your pressure can build up. Why? Because you have more pressure on one side than the other. Because this is just a filter at the end of the day. So once they get clogged up, then after that you end up having problems. You end up starving the evaporator, and then you end up having issues with the compressor. So kind of like a domino effect. One easy way to tell if your filter dryer is clogged or restricted, is you can easily get a temperature difference before and after the dryer. That's a really simple way to tell. Some systems run copper lines, which in my opinion are a lot easier to tell a temperature difference than your hose because your hoses are insulated. But if you're working on a system that uses copper lines and they have a filter dryer intact, you can easily put some sort of clamp thermometer or something on the before the filter dryer and after, and then you'll notice like a big 4 or 5 degree difference. If you see something like that, then you know obviously your filter dryer is restricted. You shouldn't have that big of a difference, maybe 1 or 2 psi at the most, or temperature, I'm sorry, 1 or 2 degree difference, but definitely not more than that. Anything more than that, then at that point you definitely have a clogged filter dryer. So that's a little tip there for those of you that can't really tell or don't know if the filter dryer is clogged or not. Just like the accumulator, you want to replace these after your compressor has failed, or anytime you've done a leak repair, or anytime the system itself has been opened to the air. So just like the accumulators, you replace any component anytime you open a refrigerant circuit, pretty much. You want to go ahead and replace them. But just like the accumulator, you want to install these filter dryers last. The reason why is because if you do a repair, like let's say you're going to change the compressor, you change the compressor, you change the filter dryer, you recover your refrigerant, you change the filter dryer first, and then you go on and change the compressor. Well, the amount of time you leave your hoses exposed to the ambient temperature, the ambient air, the ambient pressure, while you change your compressor, now your filter dryer, the new one's going to be pulling all that fresh air while you work on your compressor. So you want to do that last. That way you're not making the new filter dryer pretty much not last long. Do that last, and then go ahead and pull your vacuum, recharge it, and then you'll be okay. So this is another, this is pretty much, we'll be going into the types of TXVs that we have. So TXVs, they are pretty much a metering device. So you have your block valve, then you have your regular TXV, and then you have your orifice tube, which is a little bit different. But all of these need to pretty much be insulated. As you can see here on the image on the right, that third one on your right side, that is your sensing bulb that's insulated. So it's pretty much in charge of sensing. That's why it's called a sensing bulb, sensing the temperature of the suction line. So a metering device controls how much refrigerant enters the evaporator. It adjusts flow based on the system demand. If your bus is hot, the evaporator is absorbing all that heat. Because the evaporator is absorbing all that heat because of a hot bus, it's going to be hot, right? Your line's going to be a little bit warmer. And because of that, that's when that sensing bulb kicks in and it senses, okay, the evaporator is pretty hot. What we need to do is open up. So what the TXV is going to do is pretty much open up, make the hole a lot bigger. And when it opens a lot bigger, it lets more refrigerant in. It lets more refrigerant in and ends up cooling the evaporator. If the sensing bulb senses that the bus has reached temperature and it's not so hot anymore, then it's going to tell the TXV, hey, we're pretty much at good temperature. We don't need to be all the way open anymore. And the TXV is going to start closing a little bit. They won't ever fully close unless there's a problem. But most of the time, they're going to be either all the way open or partially open. But of course, like I've said, it adjusts based on the system demand. So if it's hot, TXV will open up all the way to try and cool the bus down faster. If it's not that hot, then it's not going to open up all the way. It maintains proper refrigerant flow to prevent flooding or starving of the evaporator. It creates a pressure drop between your high side and your low side, and it helps maintain superheat because your refrigerant is being superheated in the evaporator. So it ensures that vapor returns to the compressor pretty much. Your block valve that actually has there's like a little plate inside of here that works the same way as the sensing bulb, except it's inside the actual block valve. It's not actually ran outside like this one. I have seen situations before where this little copper line has broken, and your sensing bulb, at least on these TXVs right here, your sensing bulb is your opening pressure. So when this gets, your evaporator coil is not as cold and it's warm, your sensing bulb, there is refrigerant in this sensing bulb. So that refrigerant will boil just enough to go ahead and send pressure through your power head right here. And that refrigerant will push down, causing the opening. So if these ever break, you ever work on a system where these TXVs, you have this copper line broken, oops, move too forward, where you have this copper line broken, what ends up happening is your TXV is going to be completely closed. So if it completely closes, then you know for a fact you're starving the evaporator. You're going to start seeing one side get super cold and the other side just regular. You'll start seeing one side freeze and not the other side. So if the TXV sticks or fails, you'll see poor cooling or abnormal pressures. Typically, you'll see your high side either be a little bit higher than normal, but you'll for sure start seeing your low side, your suction, be a lot lower than usual, which can and will lead to your evaporator freezing if you let it run like that for a while. So you'll end up seeing you'll probably end up seeing more of these block valves unless you're working on like possibly like electric buses that are on the roof where the ACs are on the roof. You might see these TXVs out there with the sensing bulb, but I'm sure most of the time you guys might just see these block valves. Here in California, we see a little bit of both, mostly these TXVs though, because here in California, that's all about. It's all about moving away from gas and stuff like that, but that's for another day. So these are clogged orifices. These are orifice tubes, just another metering device. So you have your TXVs, your block valve, and then you have your orifice tubes. So they kind of work the same way as the TXV. An orifice tube controls the refrigerant flow that is going into the evaporator. There's a small opening that makes it sensitive to the breeze. That's a clean one, as you can tell on the right side, and then the one right here towards the middle, that one's pretty dirty. So these can get clogged very easily. And when they get clogged, they can restrict your refrigerant flow and reduce your cooling performance. So if it ends up getting like this, that should kind of be a sign that your system is pretty dirty, because an AC system is a sealed system. It shouldn't be pulling any fresh air from anywhere. So being that your AC is a sealed system, if you ever end up changing these orifice tubes and you see it like this, then we have a problem. I wouldn't recommend you just swap the orifice tube and call it a day, because it's probably going to get just as dirty as this one in weeks, months, or sometime down the road, it's going to get like that again. So common symptoms are poor cooling, evaporator icing or frosting, and low suction pressure. So the same symptoms as a TXV, but this one's on an orifice. So debreezing the orifice can indicate internal system contamination. So like I was saying, if you see these orifice tubes and you replace them and you see that they're pretty dirty, that should be an indicator that your system's probably contaminated. And at that point, you want to go ahead and start seeing why. Was my system running too hot? That it possibly is starting to make the flight death in the system, or was the system not properly flushed if it is contaminated? So at that point, you want to start cleaning your entire system, your entire light sets, to prevent these from clogging up again. Because like I said, if you just replace them and you put a new one on without actually flushing or cleaning the system inside, then it's just gonna get clogged up again, and you're just delaying the issue. You're just pushing it back, and then eventually by then your compressor might get killed at the very end because you just want to change the orifice and not actually clean the system. So that's it for the orifice tube. Let's see here. Relay boards. Relay boards, control boards, motherboards, many different names. But you want to make sure that the power connections, that the power wires are torqued to a spec of 18 inch pound. So this one's right here. This red one, you want to make sure that that is torqued. You have your Wago connectors right here at the bottom. You have your compressor relay, your condenser, fan motors, your high, medium, and low, which are your blower speeds. Medium's going to be over here. Low's going to be on the far right. Then you have your high for the blower, your condenser, and then your compressor. Uh, each one has its own fuse right above the relays. So if you ever see one of them pop, then that's kind of where I would start. You know, if you have your condenser relay, your condenser fuse pop, then I kind of want to start focusing on my condenser side, my wiring, my fans, are they seized up? Did any of my wires rub anywhere? Stuff like that. So you want to ensure that all wiggle connections are in the closed position. How do you know they're in the closed position? Well, when they're fully down like this. So they're kind of like a clip. If you want to pull the wire out, you literally have to lift this connection up, and it'll be kind of like an upside down L or like a 7. That's how it's how it's gonna look like when you lift up that clip. You pull the wire out and you put it back in, and then you go ahead and close it. You got to be very careful with these clips because they close fast, so they can't pinch your finger. They're not just gonna close real small or real slow. You try and close them, and they're gonna clip fast like clap. They're just gonna, so they can't pinch your finger. So you got to be very careful. You want to make sure that there are no copper strands exposed. Most of the wiring uses copper strands, so when you put them inside the wiggle connectors, you want to make sure that there's no wire strands sticking out, touching the other, another connection, or is not making contact with ground, because then you're gonna blow your fuse. So you want to make sure that all your connections are secure, nothing is loose or damaged. Make sure that everything's properly seated. Any loose connections can cause overheating or component failures, especially these sometimes I've run out in the field where these hot wires or this power wire here is not properly torqued, or even this P clamp is not on there. And what ends up doing is this wire will end up moving. It'll end up shaking up and down or side to side. And when it does that, it loosens this screw up. And when it loosens it, then it ends up happening. What ends up happening is here at the bottom, it'll just get cooked. It'll just get black. So at that point, then you would have to strip the terminal, put a new terminal on there, and go ahead and retorque it. But you can save that hassle by just making sure that there's a P clamp installed and that this was properly torqued. You also want to make sure that your temperature probe, which is very important, it's pretty much the probe or the sensor that measures the temperature of the bus, the temperature that's going back into the evaporator. You want to verify that that probe is secured. That probe is located near your air filter. So if you go ahead and remove your air filters and you look up inside, you're gonna end up seeing this probe with this little sensor sticking out. That's going to be your temperature probe. So that's what's going to be reading on your controller. So you want to verify that it's near the filter area or near the return area, and it's not actually elsewhere. Otherwise, it's going to give you a false reading, and it's going to either make the AC run a lot longer than what it should be, or it's going to make it run a lot less than what it needs to. So just want to have it in the proper spot. You want to make sure it's where the return is, just to ensure that you get accurate temperature readings. Now your drain lines and your fittings. So in AC, the evaporator, it will condensate because it absorbs heat. Your evaporator is cold because of the refrigerant and the DXV. It absorbs heat from the hot bus. So whenever you mix cold air with hot air, you get condensation. So you want to ensure that the drain lines allow water to flow downhill. Make sure that the hoses are connected to the evaporator or the drain pan, I'm sorry, for starters. And then you want to make sure that that drain line is actually going downhill and is not ran uphill and downhill and uphill and downhill, because by then, or what ends up happening is your water won't be able to flow all the way out, and it's going to end up getting stuck in your drain pan. You don't want that, because then you end up having water issues going inside the bus. So you want to make sure that it's going downhill. Check for clogs or restrictions in the drain lines. If for whatever reason, like I mentioned, if your hose is not all the way going downhill, you will have water build up in the drain pan, and then eventually you'll have water overflow leaking into the bus. And the last thing we want is for passengers to feel a little bit of water. I personally wouldn't mind it with this heat, but yeah, those that don't want to get a little wet. Outside of the bus where your hose comes out and drains, you will have something called a kazoo valve. You want to make sure that the drains have a kazoo valve. So pretty much what it is, it's pretty much meant to keep any critters or bugs from going into your drain line because they will crawl inside it. Sometimes they're located in the back of the bus at the very bottom. Sometimes they're located in the middle. It just depends. But most of the time, they're located in the back of the bus, uh, dripping down to the bottom. You can make sure that the kazoo valve is doing its job. You can just pinch it open a little bit through the sides. And if it opens up, we know that water can actually escape. Uh, if it's not opening up after you try and pinch it through the side to get it open, then it's probably stuck closed. And you might want to go ahead and get that kazoo valve replaced so that it can actually allow water to condensate out of the system. Your service ports. You want to make sure that your service ports or your caps right here, you want to make sure that they have O-rings. Sometimes they have them, sometimes they don't. You want to make sure that they have their O-rings so that they can keep the refrigerant secure and it makes a proper seal. If you don't have your O-rings and your Schrader valves end up leaking, regardless, even if you have the cap on there, if you don't have that O-ring, it's going to leak out. So you want to make sure that all your caps have O-rings. You want to ensure that the Schrader valve caps are installed and secured correctly with the O-rings. The O-ring must be inside the port cap because it helps prevent leaks. Machine Schrader caps can turn into a slow leak over time. So if you ever run into the issues where you're working on an AC system and you see that the system is low on charge, you try and find a leak elsewhere, you just can't find it. You have the system pressurized with nitrogen and you still can't find it, then I would highly recommend you check your Schrader valves. You won't know because you'll have your gauges connected to it, right? And everything will look just fine on your gauges. But the moment you disconnect them and you put your cap back on without the ring, it's going to start leaking again. So you want to ensure that you have O-rings in your caps. Your Schrader valves, they will leak from time to time, especially the high side, which is where your discharge is, because it is a lot hotter. So this is pretty much a potential leak area. Easy way to tell is like in the image shows you right here. You'll see like oil stains. Oil stains are a big indicator of leak points. So if you see an oil stain somewhere on a feeding or somewhere, there's a possibility you might have a leak there. But all in all, make sure your caps have O-rings on them and that the kazoo valve is actually installed, because if it's not installed, then what ends up happening is you'll have a bunch of bugs or critters going up inside. They clog your drain. Your drain is clogged. The water goes back into your drain pan and ends up leaking inside your bus. So that's the whole purpose of this kazoo valve here. So leak testing. All fittings are potential leak points. Every single fitting that you can think of, from the compressor all the way to your evap, filter dryer, TXVs, and back to the compressor, accumulator, all of them. They're all potential leak points. Look for oil residue at fittings, your hoses and coils. You could use an electronic leak detector. They can detect most refrigerant leaks. In my opinion, not all of them, but majority of them, yes. It just depends, because if you have very little refrigerant in your system, you probably won't be able to pick up the leak itself. That's when you use something called a bubble test. That's when you conduct a bubble test. So if you want to use a non-corrosive leak detector solution on all your fittings. So if your system is low on charge for whatever reason, or let's say you've already done a repair and you just want to pressure test it to make sure that it holds. At that point, you can pressurize it with nitrogen. And once you pressurize it with nitrogen, you can go ahead and spray your leak detector. We like to use Big Blue, which is right there in the screen there. And spread all over our fittings to see if you have any leaks. If you do have a leak, what ends up happening is you'll start seeing a bunch of bubbles come out of the fittings when you use that nitrogen test and the micro leak detector solution. So I prefer to use that combo because it helps me find the leak a lot faster and a lot better. But you could always use your leak detector if you still have refrigerant in the system. And for those of you that don't know how it works, they pretty much have the leak detector. You're just going to be putting it all over the fittings, and then it'll end up beeping. The faster it beeps, the closer you are to the fitting, or to the leak, I'm sorry. But you can never really identify the actual pinpoint until you use that bubble test. So you want to go ahead and pressurize the system up to 275 psi. You pressurize it with nitrogen, and then you start using your solution here. Spray it all over your fittings. or spray it where your leak detector was beeping at near that area. See if you can find it there. Bubbles indicate a leak location. So pretty good combo to use to find any leaks. After you've done your leaks, after you've done your repairs, you want to go ahead and pull a vacuum, of course. So all of our systems utilize 134A with the exception of our electric Revo 8 Global, which uses 407C refrigerant. Moisture is a deadly enemy of any AC system. It'll contaminate your system. It'll create the Black Death. It'll pretty much clog all your components, make the compressor go out. It's just you definitely don't want moisture inside your AC system at all. Um, they non-condensables. They result in high discharge pressures. They create acid, sludge, and formation of acids from high temperature. They can freeze up at the metering device, and of course, with moisture and air, you can get rust within the steel fittings. So, anytime you do any repairs or anytime you have the system open to atmospheric pressure, you want to go ahead and pull a vacuum on the system once you're done. As you can see here, you see a couple images. Some guys have their setups. Some of them have their vacuum pump here. Then they have their gauges hooked up to that compressor. This is on the Revo E. So these are all on the roof right here. But then you have these over here on the side. So just want to make sure that you pull a good vacuum on it. If you pull a good vacuum, you know for a fact you don't have any leaks in your system, and you hardly have, if any, moisture at all in your system. So the least amount of moisture you have in your system, the longer the AC is going to run, the longer the parts are going to last, and the less work you're going to have to do on the system. So when it comes to pulling a vacuum, you want to go ahead and pretty much use your micron gauge. I would recommend you use it. Please do not rely on your compound gauge. Only tell you if you are in a deep vacuum or not, if you do have a good vacuum, because you want to use your vacuum gauge, your micron gauge. Anything that reaches 500 or below is good. So if you just rely on your compound gauge only, on your gauges, it can read -29, -30. Most of the time they stay at 29, right? But as you can see here on this chart, let's say your gauge is reading 29. It might not be able to tell you 29.13. It might not tell you 29.76 or 29.84. It might just say 29. So let's say you rely on the compound gauge only and it reads 29. At boiling temperatures at 72 degrees Fahrenheit, but your microns are at 20,000. So big difference. You won't know that if you're just using a compound gauge. That's when you use your micron gauge here. If you use your micron gauge, it'll actually read microns. The longer you run the pump, the more of a vacuum you're going to pull, which is a lot better. You pull more moisture out, and then the lower your microns are going to be. So you want to aim for 500. And also, if you use a micron gauge, it is a very good indicator of letting you know whether you still have a leak or not. If you're pulling a vacuum and you just can't get below 1,000, you can't get below 2,000, or let's say you get below 1,000, or you get to 500, and you go ahead and turn the vacuum pump off, you have your gauges closed so that your micron is just reading what's going on inside your system, and you see that micron shoot straight up from 500 or 1,000 all the way up to 2, 3, 4, 5, 6, 7, 8, 9,000 microns. If it shoots up that high immediately, you know for a fact you have a leak. So that's why I like using a micron gauge as well, so that in case for whatever reason I missed a leak, I didn't find it, or I fixed one leak thinking that there was only one, but there was in fact 2 or 3. I figured it out with the micron gauge. It actually told me, it would tell you, hey, you still got a leak if it shoots that high. If it shoots up a little bit slowly, you reach 500 and it goes up to 550, 560, and it stays like at, let's say, 600 for a good hour, then you know that you probably have a little bit of moisture in there, but not too bad. But you definitely don't have a leak. That's only when the microns shoot all the way up. But a vacuum gauge is more accurate than a compound gauge, and it responds to minor changes in the vacuum that can't be seen with the compound gauge. So if you don't have a vacuum gauge, I highly recommend you get one, because it ensures that your system is actually dehydrated. It makes sure that it's actually evacuated, that you have no moisture in the system. And like I said, it also makes sure that you don't have any leaks in the system. So definitely get one if you don't have one. It helps out a lot. Lastly, here we just have a standard preventative maintenance guideline, something that we use. Um, this chart, I like this chart because it even tells you how often to check it and whether to check it with if the system is off or if the system is on. So daily pre-trip inspections and maintenance while the system is off, you want to have, check the conditions and the tension drive belts. Um, Make sure that everything's running as should. Now to have the system on, then you can check your evaporator fans, your system, get an amp draw, all of that good stuff. But this chart right here, it's a pretty good guideline. We have our daily, our weekly inspections, our monthly inspections, quarterly, so on and so forth, all the way up to annual. So just a standard maintenance guideline. Pretty much something good to look at. Keep up with the maintenance. The more maintenance, or the more you keep up with the maintenance on the system, then the longer it's gonna last you. So you won't have any issues with your AC at all, whatsoever, if you keep up with the maintenance. And you can also consider or use the maintenance as while you're doing the maintenance and you happen to see any oil stains, you can even find ways to prevent the system from failing. So in a way, you kind of are doing the maintenance if you are doing the maintenance, but you're also it's called the preventative maintenance, in other words. So you do your maintenance on it. You can find ways, if you do find anything wrong with the system, you can catch it before it actually fails. That way it doesn't leave the vehicle without AC in the middle of the road. So definitely keep up with the maintenance. It's very, very, very important. Now, as far as the presentation, this pretty much sums it up. If you guys do have any questions, I'm all ears.
All right, does anybody have any questions? Johnny, I had a question
Sure.
on, because I was at another place that we were working on their air conditioning, and the receiver dryer was filled with desiccant because of it had excessive oil in it.
Mm-hmm.
So how would you go through and flush the system? Now this desiccant had gotten into the rest of the system. So say you had a contamination in your system that you needed to clean right out. What would you use, and what would be the procedure to clean all that out?
Yeah, of course. So what we would normally use if your system is contaminated, whether the desiccant bag broke or you have the black death or anything like that in the system, what I would end up using is non-chlorinated brake cleaner. So we use that just because it evaporates very, very quickly after it's done. So we would buy like your 5-gallon or gallon non-chlorinated brake cleaner. We would use our nitrogen as well in series so that the nitrogen pushes that non-chlorinated brake cleaner into the system and it flushes it all the way out. We would use it on all our hoses if necessary, or the copper lines if necessary. You can also use it on your coils. It just varies on what kind of coil you have. Some of them are your copper and fins. Some of them are micro channel, which are aluminum. On those, the holes are a lot smaller on your aluminum fins. So because the holes are a lot smaller, you're probably going to spend a lot more time flushing those coils than your actual tube and fins, because the tube and fins, the hole's a lot bigger. But you definitely want to use non-chlorinated brake cleaner to use it. And then your nitrogen to go ahead and push it all the way into the system and out the other end. You don't want to use it with your filter dryer in place or the accumulator in place. You want to have those removed, and then you want to go ahead and start flushing everything out. Because if you do try and flush it with a new filter dryer or the old one still on, or with the new accumulator or with the old one still on, it's all going to get stuck at the filter dryer, because the whole point is to try and filter everything. And the same goes for the accumulator as well. So you want to have those two removed, either or. Sometimes the systems come with both. Sometimes it just comes with one individually. You want to have those removed first, and then you want to go ahead and start flushing everything out.
Okay. Does anybody else have any questions? Not seeing any. If you do come up with any questions, please let me know, and I will make sure that the questions are answered. I know, if you have a question, we're all working on the same kind of systems. This way we can all get the answers. So thank you, Chris. or I was expecting Chris, Johnny for the meeting.
I'll tell them thank you.
Yeah. You guys always help us out and work with us and stuff. So we appreciate that.
Yeah, of course. I
Yeah,
appreciate you guys'
thank-
time. I appreciate everybody that was here.
Yeah, with a lot of information. It should be good. Like I said, this meeting was recorded and we're going to post it to our channel. So, you know, I strongly recommend this, especially people have new technicians in that are working with AC for maybe the first time. It's good to be able to understand exactly how the system works. Definitely will help with your maintenance. And, you know, for us people that have been doing it for years and years, it's always a good refresher. That's why we like to do this at least once a year in the beginning of the season. So thank you, Johnny, for your presentation.
Yeah, of course.
Our next meeting will be held on April 15th, 2026, of course. And this one is by popular demand again. Mickey Jones with Capital Region BOCES will be presenting on PESHA laws and regulations. She'll also be going over, you know, what DEC is looking for at our fuel islands, OSHA regulations, shop inspections. That's just to name a few things. She's pretty in depth, but I know she presented for us last year, and this year I'm getting a lot of people that want that presentation again or an updated one. And so that's going to be April 15th. Our summer seminar is coming together nicely. Again, July 15th is the setup. July 16th is the show. We do have rooms available at the Best Western. So, and that link is right on our page that I sent to everyone. If anybody doesn't have it, please let me know and we can make sure that you receive it. I want to say thank you so much for the meeting topics that I've been getting. So keep those coming. We have another one that is wheelchair lift operation. We're going to put one of those together. That was another one that came across. We also had Collins Bus. They wanting to do a presentation. In fact, they're going to be at the summer seminar this year. They're going to be bringing a few of their buses. So, you know, the industry is changing a little bit. We're moving forward and we want to stay right there with it. So does anybody have anything else to add to today's meeting? That's sort of all I have. Not seeing any. If anybody does, please send me an email. And like I said, keep the meeting topics coming. And we will see you guys all next week or next month for the next meeting. Thank you all for being here.